and then we could wait. I'm not going to wait for it to come back up, but you can see it's going to take it a little while to even come back up to room temperature there. All right. So let's zoom back in on our prediction part. Okay. So a couple things. We know that we were right. It did drop, right? So we can definitely confirm that prediction. We thought it would drop instantly though, and it turns out it didn't. It actually dropped over roughly about 2 seconds. All right.
所以说，你看预测哈，它的温度下降没有做很好，很漂亮，但是它可能不是突然下降，可能会降，大概经过2秒。
We thought it would drop about 2 degrees, and we do see that it did roughly drop, but let's further investigate how much it did actually drop. So I'm going to go back into my tools and select my range here. So let's say we're going to go from there to there. And let's just take a closer look at that. So we see that over roughly 3 seconds, it dropped 1.5 degrees. Okay, so you were right, it did approximate about 2 degrees of dropping, but that happened over 3 seconds. All right, and you're my more advanced crowd, so I'm going to skip over, why it dropped. I think, you guys already understood that part. But my more advanced crowd could maybe think, why did it take 3 seconds to drop? What was the gradual decay there instead of an instant drop?
但你的预测是对的，没有错啊，温度。但是他说这个做出来结果是差不多3秒钟才会下来啊，大家来聊聊看。
Okay. And I'm not expecting an answer today, but that's a good example of how we can now start bridging these hands-on experiments, these beginnings of the lesson into deeper discussions, right? So we're not only confirming prior knowledge, we're not only confirming what you guys already understood in terms of the relationships between pressure and temperature, but we're opening the door to kind of deepen that understanding in different ways, okay? So that's one of the really nice things I can do with this type of probeware, this type of equipment. I'm going to go back to my journal again. So I'm going to go ahead and throw this page in my journal too. Let's go open up the journal and take a look. So as you can see, I have my different screenshots. I have my prediction. I have a place I can even add some notes. All right, so we observe the temp
他说
dropping.
这个东西做得很好，还可以把你的时间报告写在里面，预测什么东西都会写进去。
1.5 Celsius over 3 seconds. Right, so students can come in and directly start typing their notes. All right, and let's go ahead and save this. So I'm going to go ahead and save my journal to my desktop just to show you what it looks like. Okay. So there's my journal in a folder. All right, so you see inside of this journal, I have all the original pictures. So I have all those screenshots that I captured earlier. I have these text files, and the text files have, this time, date, stamp, but they also have all those notes that the students type, okay? And more importantly, it all gets wrapped together in an HTML file. So in this HTML file, it takes all my images and my notes, and it puts them all together. And the reason why we chose HTML, one is there's not a computer or electronics device nowadays that doesn't have a web browser on it. So if the students were to email this to the teacher would be able to open this up no matter if they had SparkView running or not. Right? The other reason is because this opens up very easily inside of Microsoft Word. So the students could open this up inside of Word, finish formatting their lab report, and now they have something that they can deliver to the teacher, showing them what they've learned in that lesson for the day.
学生可以把这些东西做完了哈，就把 email 给老师，老师就可以看一看，跟他讨论，还是做一些其他的后续工作。
All right. So let's go back into SparkView. So that's just real quickly the show path. That's taking one measurement, showing a graph, and quickly diving in. Let's go back to the home screen, and I'm going to show you another path, and that's the open. All right, so the open path goes to open up a pre-built activity. All right, and the one I'm going to show you today is an activity that's already been developed by our partners here in Taiwan, by Kuyang. All right, and I believe we have are we mostly physics teachers here today? Yeah, majority physics. Let's open up one of the pre-built physics ones. And we'll go with the Ohm's Law one that we opened up yesterday. So this is what our pre-built, what we call Spark Labs look like. And Spark Labs are taking the measurement and the probeware technology that you've already seen in the show graph, but we're combining it with the pictures, text, and response boxes for students to have a complete lab experience. So as you walk through this, students are guided, how they're going to collect their data, how they're going to share it with teachers. All right? That's outlining the journal that we've already talked about. Right? And they're getting some of these questions and pictures they typically would either get from a textbook and a reading they've done the night before, or maybe this would even be kind of like the PowerPoint that the teacher would be using in the classroom to introduce the students to the lesson. All right, so in this case, we're introduced to Ohm's Law. There's Mr. Ohm himself. All right, we have our equipment. This is what we're going to be using. And this uses one of our boards, very similar to the one that you saw earlier. All right, and here's an interesting part. This is actually asking the students to think about how they're going to do this activity. Right? So this is another step of us trying to shift away that traditional approach of you do this because the teacher said so, to the students thinking about why they're doing this, right? The students are trying to become the scientists themselves. Right? I know I'm doing my job as a science teacher if I'm creating scientists and not just followers of what I tell them to do, right?
他做这些东西哈，都是事先把这个东西做好，然后学生可以看，老师可以也可以教啊，然后让学生仔细看，老师也不要烦老师，还是烦学生等等。然后你可以看这些很多东西都是我和我的研究生还有学生翻译做出来的，来这边可以帮助老师嘛，可以试试看。
Okay. So once again, the prediction page, very important. So students are going to go ahead and predict what they expect the relationship to be. And in this case, I have my current and voltage on my axis here. All right. The other nice thing that this does is it takes my data collection and it puts it right beside my instructions. And this is another key step for teachers and students, right? They're not afraid to get into the technology, to start using the technology, because there's a safety net for them. There's instructions for them to fall back on in case they forgot maybe how to do a prediction tool or how to use the analysis tools. Okay, there's the setup information. Once again, that would be something they would have to go look at, you know, a lab book or some other picture the teacher provided. We're taking that setup information and putting it into the same software so the students are having a continuous experience as they progress through this lab. We're removing those distractions, right? And then as the students work through the activity, they're asked to go ahead and start responding to some assessment questions. And this is a kind of a pre-question for before the experiment. And the students are asked to pick from this multiple choice. And they can go through and they can type, maybe they think their best answer is B in this case. And as they go through and they make these assessment responses, they're just going to add those to their journal, right? And it's going to be part of what they submit to the teacher later on. And this activity, you actually walk through 3 different resistors. This circuit board has 3 different resistors on it, and it's very easy just to kind of move your cables from one to the other as you walk through the activity. Okay? So I'm not going to walk through the 3 parts of this, but you can kind of just see how the lab evolves as it walks students through data collection and then gets them back into the assessment. So at the end of the activity, the students are coming back together and doing what we call these summative questions. These are summative analysis. All right, so these are longer form responses where students would be responding in more complete sentences type things for this teacher. So we understand that the relationship between voltage and current is this, right? And we know that because of this, right? So we can kind of go through and have more detailed discussion of what the students learn. And of course, at the end, we have to have multiple choice. I'm sure Taiwan, just like the US and many other countries, has standardized testing, right? So there's always those multiple choice questions that we have to prepare students for. So we have these built-in sample multiple choice questions, problem solving, that we have to prepare the students for on these larger tests.
这些翻译各位都可以看懂，都是我带领学生翻译。但这些做的话，它有个好处，它可以很多国家都是做类似的一样的东西，只是文字不一样，可以做个比较。
Okay. And so that's the open path there. So we've taken an activity that the teachers already put together or an activity that Pasco's put together and had translated by our partners here in Taiwan, and then having the students walk through that complete experience. So that was open. We started off with show. There's one more that we haven't looked at, and that's build. Okay? And build allows you to take any sensor, any calculation, any data set that the students can enter, and they can build their own experiment. So now we're progressing to that place where students are thinking for themselves. They're designing their own experiment. They're working without any instructions from the teacher, right? So they're kind of developing their own experiment. And this one I'm just going to go ahead. Sorry.
那他后面按个建立，就是说很多 sensor 都已经建好了哈，你就可以学生可以建立自己的实验过程等等。
Okay, and this one I'm just going to build a silly experiment here with my camera. So we're just going to take a look at maybe what happened to my balloon afterwards. And I'm going to put in some text boxes. So here's the sample page, and I'm just going to use a built-in camera I have in my computer here, right? So I can take those live images. We saw the USB microscope earlier, but I can just use the camera built into my computer. So here's what's left of my balloon. There's the temperature probe, right? So maybe you just want to take a, let's go that way. So maybe I want to take a snapshot of that. Smile. All right, so the students can go through, take a picture of what the experiment looked like as they were setting it up. I'm not only getting those images here on this page though, but I'm also still getting live data collection. So I still can go ahead and, all right, there's what the room temperature was whenever I took that picture, right? So I'm getting this integration between live images, data collection, and students' thoughts, right? So I can come over here and enter their thoughts too. So this is the temperature in room, right? So combining all these different places of information really helps support students making sense of what's going on. So they're not just out exploring, you know, what is this motion and this thing that I've never really had experience with, right? But they're actually connecting these hands-on experiences to data that they're getting instantly, right? We're trying to bridge that connection, right?
所以他现在可以把照相的实验过程照相啦，还有数据，还有你的报告，通通把 combine 在一块。
Okay, so that's just a quick build example. I'm going to take that same idea of taking live images and I'm going to marry that to the demo that you saw earlier with the motion sensor. So now I'm going to switch back over to Capstone.
那现在做一个那个移动的，做给你看，它是怎么做的。
And hopefully my windows will behave for me. Okay, so this is a Pasco Capstone. As I said earlier, this is designed for slightly higher end users. Okay, brief word about the 850. We'll take a closer look at this in a minute, but some of the key features of the 850, as you can see in the front, I've taken our science workshop sensors, our analog and digital sensors, and I've combined them with our passport sensors. This is Pasco's first interface that's provided access to both sensor lines. A couple of other new things about the 850 is it has 3 signal generators over here on the right side of the box. The top one has high power output. It outputs up to 15 watts, so it'll do 15 volts at 1 amp. And the 2 ports below that is a high frequency signal output. So it can do over 8 different waveforms at frequencies up to 250 kilohertz. Okay? And why would I output something at 250 kilohertz if I couldn't measure it? This measures at 10 megahertz. So this is over 50 times faster than our Science Workshop 500, over 20 times faster than our 750. So this is by far the fastest interface that we've ever made.
向各位介绍一下，它这 A50 这个850这个很好，它可以接12个感应器哈，然后这边还有一个电源供应器也在这里面啊，还有下面信号产生机也可以在里面，你都不要买信号产生机，也不要买电源供应，都拥有，而且这些全部都是电脑可以控制，你要它几伏特出来就出来，信号多少都出来。因为我们以前做实验不知道买信号产生机什么电源都不要买，通通在里面都做好了，而且它这连那个sensor 都接到上面，通通一个字把你做完，而且它还有一个软体非常好的软体叫 Capstone 啊 Capstone 这个好像有这个好像先进的什么东西那个名字哈，它就可以做一大堆的实验，全部都做好。不过通常这种东西通常都在比较好一点的实验室，我们来做这个东西。那现在介绍给你听。
Okay, for some of you who are Data Studio users, how many of you are Data Studio users? Okay, a few of you are Data Studio users. All right, you'll recognize a couple things similar, like having my different displays. It's drag and drop, just like Data Studio was. So I can drag that. One nice new feature of Capstone is it has these preset places around your screen. So it helps you lay out your pages as you drag and drop these displays in there. So there's a graph. And I'm going to connect my 850. Sorry, give me 1 second there. So there's my 850 connected. And let's go ahead and bring in position. So there's my position graph. All right, and can I get a assistant move my cart? All right. Can I get a volunteer? Okay. Yep, you got it. Okay. So I'm just going to want to start right here, and I'm just going to push it so it comes up here. So go ahead and practice. Yeah. No, that's okay. That's close enough. Pretty good. Okay, so hold that position. All right. So let's go ahead and take a look at what that position looks like. All right. And I want us to start about 15 centimeters away, so you can move it just a little bit away. But you can go ahead and see the motion that I'm trying to get here, right? I'm trying to get that motion that we talked about earlier, the cart up the track and coming back down the track again. Okay? So let's go ahead and make a new page. So Capstone's designed with this idea of workbooks, so you can have multiple pages throughout your activity. But in this one, I'm going to combine it with an image. So let's add a movie to this. And I'm going to use this camera. This is the camera at the top here. So as you can see, there we are. All right. There you go. All right. So I'm going to add in my position graph right beside that. Okay. And let's go ahead and delete that last run. Okay. Perfect. Very nice. Thank you. Thank you. All right. Okay. So why is it so important to take that idea of marrying these images to their data? What does that allow us to do? Well, one of the nice things that allows us to do is ask deeper questions to the students. For example, what happened in this experiment? What was the position the greatest? When was it the max, right? So when was it the furthest away? And students can now go back and kind of scroll through their data and actually see the cart coming up the track. There it is at the max, and there it is going back down the track again, right? They can take any experiments, any data, not just position, but any data, students can come back and they can play back the data, right? So if they want to come back and watch that later again, okay? So we're taking that same idea we touched on earlier, trying to bring these hands-on experiments, and we're taking them to the next level, integrating things like camera, right? Live movie capture, sync with the data. Okay, so that's one of the new things with Pasco Capstone. I'm going to try to switch over and show you some of the key functionality of the 850. All right, so bear with me one second. Any questions so far? No? Okay. Perfect audience. All right, so I'm going to switch over to the 850. And in this experiment, I'm going to look at circuits. So I already have a circuit board already put together. All right, so this is my circuit board. All right, and I have three components of this circuit board. I have an inductor, my L, I have a capacitor, my C, and my resistor, my R. Okay, and I've always said LRC, but
RLC.
RLC, okay. Whichever one you prefer, right? As long as they're in series. So this is my inductor up here. I have an inductor of 6.8 millihenries. This is my capacitor of 3,900 picofarads, and my resistor down here at 3.3 kiloohms.
好，你们可以看，它现在这个东西上面哈，我们就有电容、电感还有电阻，它每一种大概有2、3个，电容有几个，电感有几个，电阻有几个，这样做起来。
Okay, I'm going to be powering the circuit with my voltage supply, so that's what's plugged in over here. And then these two things are voltage sensors. So I'm going to be measuring two voltages. One is going to be my source voltage across the whole circuit. So it comes in here and goes out here. The other is just the voltage across my resistor. Okay?
它现在做起来有那个就是那个电源供应器，一个是输入，一个输出在电阻那个地方。
So I'm just going to tell the 850 that I have two voltage sensors connected to it. Okay?
那接2个感应器在那边是电压感应器。
And now we're going to switch over to our signal generator. Okay? So, like I said, the signal generator has a couple of nice features. One is the wide variety of signals that it can output. The other nice feature is it has a sweep ability. So I'm going to single sweep a range of frequencies in this activity. I'm going to go from 1,000 hertz to 70,000 hertz. Okay? And you might ask yourself, why would I do that? Well, traditionally in an LRC lab, students get one frequency at a time, right? So they do one frequency and they take one data point, right? And they'll graph it later, maybe if they're lucky, right? But typically they just have this big table and they have to manually type. I'm going to visually show students what happens to this circuit as I sweep across that frequency range so they can see actually what's going on in the circuit as it's going through this phase.
他现在用了，我们以前在实验室都是用一个固定的一个频率来做哈，他现在不会，我用1000到7000，我做给你看，我全部给你做。
So I'm going to set my initial frequency to 1,000 hertz. I'm going to set my final frequency to 70,000 hertz. And I'm going to do this over 25 seconds. So I'm going to provide plenty of time for students to see this transition.
So 25 seconds is one frequency for 25 seconds also overall.
It's going to be overall. So 25 seconds to go from 1,000 to 70,000. Okay? All right, so I'm going to leave that open right there for 1 second while I switch over here and open up a scope. And I apologize, my screen is a little small, but I think you'll be able to see. So I'm going to add my 2 voltage sensors to my oscilloscope. So that's voltage A, this is voltage B. Okay. I'm going to go ahead and turn on a trigger, okay, because I want to see a nice smooth circuit here. And the last thing I want to do to my oscilloscope display is I want to adjust it to a time window that I can really see this circuit form, right? And you'll notice one nice thing Capstone's going to do for me as I do this is I know roughly the time period I want to look at. But notice at the bottom of my screen here, Capstone's adjusting the sampling rate to make sure that you have plenty of data points depending on that time window. Okay? So I'm going to go ahead and just comb through, and I'm going to get it to where my sampling rate's roughly 5 megahertz. Okay? So this is a really fast looking at a short amount of time with lots of data. Okay? So there's 5 megahertz right there. All right, now one last thing I need to do is I need to switch to sampling mode. And so far everything you've seen today has been in continuous mode. And continuous mode means you start and it continuously takes data at a sample rate until you hit stop, right? In this mode, I'm not concerned about saving all this data as much as I am about seeing nice smooth plots of my signals. So I'm going to turn it to fast monitor mode. And that's going to allow the hardware and the software to burst their data at very high sample rates but not slow down the system trying to save all that data. Okay? So that's my first mode. And let's open up our signal generator again and just kind of see what happens. So let's begin monitoring first of all. Hopefully we see our voltages in there. Okay, just to give you a point of reference, the voltage across my entire circuit is the light blue one here. So this is my across the whole circuit, and this is across my resistor is the darker blue one here. Okay? So I'm going to stop. I'm going to do that one more time just to kind of help you see what's going on here. All right.
就简单讲，就是输入和输出的电压哈，它很快在电阻上的电压改变化情形来讨论。
It's kind of nice just to watch, right? It's kind of pretty just to watch. For those of you who really are starting to think ahead of me here, trying to understand what an LRC circuit's doing, is you're actually watching the circuit respond to these different frequencies, right? And when I start off at these low frequencies, these waves are not anywhere close to being in sync with each other, right? But as I pass what we call the resonant frequency, they all start shifting and lining up, right? And at that resonant frequency, they're not only lined up with each other, but their amplitude goes up a little bit. But as soon as I start shifting out of that resonant frequency, that amplitude starts coming back down again. So students are actually seeing us reach that resonant frequency and then move out of that resonant frequency again. So they're actually seeing those waves change as they're coming in and out of resonance.
所以的输入输出那个那个电压哈，会随着频率不同哦，所以会有改变，shift 的改变。
Okay? So this time I'm going to watch it again, but I'm going to ask my students to stop it when they think it's in resonance. So let's say we stop it right there. That looks like things are pretty close in resonance with each other. I have a max amplitude. I have waves that look like they're right on top of each other. So now I want to figure out, okay, what frequency is that? Right? What is the resonance frequency for this circuit?
这就是同向嘛，哈，各位都知道哈，同向状态的时候，那个频率是多少？
Okay? So what would I use to find the resonant frequency? Well, I could do a couple things. I could have students measure, this time interval, and I could have them calculate the period, right? Or I could introduce them to this idea of fast Fourier transforms, right? An FFT, right? That's actually taking this data and it's doing its own analysis of the data to show you what the frequency is. So I'm going to open up an FFT display.
他现在用 FFT 就是那个对，Fourier 什么 Fourier analysis 是什么？transformation analysis 啊，那个东西哈，来做这个分析，你看。
Okay, so that's my fast Fourier transform, and this once again is another big improvement over Data Studio. Data Studio had an FFT, but it was very limited by the number of bends that it could break down the signal to, and it looked kind of like this. It would be really chunky, and it would be over a very big range, and you couldn't quite figure out what the frequency is, right? So even if I start zooming in on this, even if I identify that it's somewhere around 30,000 hertz, it's still kind of blocky, right? It's still not doing a very good job of showing me what that frequency is. So with Capstone, we've added that ability to actually change the number of bends there, and I'm not going to go too deep into the analysis of an FFT, but I'm just going to show you real quickly how we can do that. So I'm just going to increase the number of my bends. And notice it dynamically live recalculates your fast Fourier transform for you. It was that fast. Okay? So let's go ahead and let's adjust our bends. So that looks pretty good, right? That looks like a nice... There we go. So now we're able to start seeing some definition of these bends. So let's say that students want to know, okay, what is that frequency? What is that frequency where I see that real big peak, right? That's probably what the actual frequency is of these waves. Well, I'm going to turn on my tool, and notice my tool kind of snaps to these data points. So I don't have to be exactly on it. I can just kind of let it snap to it. So there's roughly my frequency. All right, 29,000 hertz. All right.
啊，就是说同向啊，它频率应该是就是那个数字哈，它可以做到这样的地步，给你分析出来给你看。
And if you actually were to go through and do the calculation with these numbers here, the actual frequency is 30,200 hertz. So I'm very close to arriving at my actual resonant frequency for this circuit. So this is an experiment. Students would typically have to spend quite a amount of time looking at different frequencies, manually writing down what the resonation point is, maybe doing a linear fit to see what that resonation is. I've taken that and I've dramatically simplified this concept. Once again, allowing students to further explore their deeper understanding of this idea without worrying about the technology, without making the technology too complex. Okay?
There are curve fitting there. Curve fitting.
There is curve fitting. There's not curve fitting in an FFT because you don't typically curve fit an FFT. But let's go back and look. We have some time. Let's go back and look at our motion, and we'll show you a curve fit for the motion. Okay? So,
my student use the other way to find the frequency. They use this data export to the text file, then re-import the text file, then use the...
And then you have to open up Excel and then do a fit or something like that.
Well, you still can use the
Yeah.
Data Studio.
Yeah. You still can do it that way, but we're trying to eliminate those steps, right? We're trying to make it that it happens all in one place. That way students aren't having to worry about, okay, well, I've got to move my data around, because the more steps you introduce, the further away they are from their actual experience, right? And the research shows that the further students are learning away from their hands-on experience, the less effective the hands-on experience was. Right? We need the learning to happen really quickly after they actually did the experiment. Right? You're going to learn the most about this if you get to that point of learning right after seeing this display. Right? You saw this transformation of these waves. The sooner I can connect that to this frequency, the better chances of you remembering that later. right? So I'm going to open up a graph again just so we can show curve fitting.